Hi, I'm EP Book, and today I'm going to be talking about 32U4 based Arduino boards. I hope you enjoy. Now, I said 32U4 based Arduinos, but what does it mean? Well, as far as I know, there are two Arduinos on the market that use this microcontroller. That is the Leonardo and Micro. The 32U4 microcontroller features a built-in USB interface that is HID compatible, which is just a fancy word for mouse and keyboard. And that's the pretty much only difference between this microcontroller and your traditional ATmegas found on the Arduino Uno. Okay, so let's do some programming. First, I will do just some simple sketches to prove it can operate as good as classical Arduinos, and then I'll be showing you how to use the mouse library and the keyboard library. Let's go! Alright, so for the first code we need to do some wiring first, since this clone doesn't have an LED attached to pin 13. It doesn't even have a pin 13. So we're going to use pin 10. What we are actually going to need? We are going to need a breadboard, over here, an LED, a 220 ohm resistor that has a color code of red, black, and brown. Of course, our Arduino, and some jumper wires. So let's go into it. So I have the breadboard. I'm gonna plug the Arduino into it. There. And now I'm actually going to take some of the jumpers and put them so the power and ground will be on the power rails of the breadboard. So that's our VCC and GND, and now we have to put the LED onto pin 10. LEDs have markings, so cathode is always the one where you should feed the positive power, and the anode is the one where the current actually flows out of the diode. So how you can tell the cathode and anode? Well, cathode doesn't have this little flat over here, and cathode also has a longer lead, where ground has a shorter lead, the flat on the side, and also if you actually look inside, it actually has like a bigger conductor inside. So that's how you can tell the polarity of the LED. So now I'm going to plug it in. I plugged it in so the longer lead actually goes towards the pin 10, and the shorter lead will actually go through this resistor to ground. That means that every time this pin will go high, the LED will turn on. But if you insert the LED the other way around, then it would mean that you would need to put the resistor to the VCC, so the LED will turn on always when this pin goes low. But I'm going to use it as I want this LED so it will turn on every time the pin 10 will go high. So all I just need to do is put a 220 ohm resistor to the ground. And then just a small jumper. And there is our circuit complete. Now let's write the program. Alright, so let's start writing the code. Now the code is going to be pretty simple since we're doing just the blinking program. So First of all, to start the code, I'm gonna define all the global variables. That means you can use either an integer or a constant integer or a define to declare the pins that you are going to use. So I'm going to use #define. Now I'm going to call that pin LED, and the pin is going to be a pin number 10, because as I said, the micro doesn't have pin number 13, so that's why I have to use pin 10. Alright, that's the first portion done. Now let's move on to void setup. So writing down void setup. Now in the setup we'll just need the pin mode. So pin mode now we have called the pin LED, and it's going to be a 0, aka output. 1, if you write 1, it stands for input. If you write 0, it stands for output. So 0 for output. Now I'm going to write void loop, and in the void loop is going to be actually our blinking blink. So first we will actually pull the pin high, so digital write LED 1, then we're gonna do a delay, let's say of 250 milliseconds, and then digital write LED low, because we want to pull then the pin low, and then another delay of 250. Oops, oh, what did I do? 250 milliseconds, and that should be our sketch done. Now let's check if we have the correct port. Oh, that's true, I haven't plugged it in. So let's plug it in, shall we? So I plugged it in. There is no code on there. So now I'm going to hit upload to upload the sketch onto the micro, and we see the LED is somewhat blinking, but it's blinking pretty dim. Maybe let's try to replace that with a different LED. Now I think it should be better. So, and now we prove that it can actually run programs as usual. Now let's move on to the more interesting part, where we actually get into the mouse library and the keyboard library. Alright, so next up we are going to learn about the mouse and keyboard libraries that are out there. So first of all, we're going to start with the mouse library. So we'll first include it in our code. Alright, so we'll include it in our code, and it's called Mouse.h. Mouse.h. Next up, we don't actually need to declare any pins, as for our purposes we won't need any. So we'll just continue straight on with void setup. And over here we have to initialize the library, and that's pretty much all we have to do, because we have no inputs or outputs or no other stuff that we should do. So it's really simple. We just write mouse.begin, and that's it. Next up, we're going to write the void loop. So now it's the part that goes a bit more interesting. So what I actually forgot is I'm going to use a function called random, which will just generate a random number. So I actually have to include in setup random seed, and let's say it's going to be the analog input A0. Now this can be anything you want, but it's just, to give it the variety. And yeah, so let's continue on the void loop. So mouse.move, and now we're just going to do random and now we want to have the direction. So let's say we want to generate a number between 0 and let's say 500. Okay, so this first part, there are actually two integers that you have to put in the brackets for the mouse move. For the random function, there are actually another two values you have to put in between the brackets. For the random is the limits of the random number being generated. So if I say it should be 0 or bigger, but it's going to be less than 500, so we will actually generate a random number from 0 to 499, which should be sufficient enough. And the mouse.move function actually requires also two values that we randomly generate, and those values are for x and y move. It's not on axis, it will just move the mouse on the one or other direction. So yeah, now let's type in the second random. There's going to be 0 and 500, and there. So now what we just did is that the mouse will actually move to a random location, and then what we are going to do is we're gonna do delay of, let's say, 250 milliseconds, and then we're going to make the mouse so it will actually left click. So we're going to say mouse dot press, and now which button? For the left button it is left key, I think. Okay, so one correction, it's not left key, but it's the mouse button is actually called mouse left. There. Then we wait 100 milliseconds, and then we will release the key. So mouse.release mouse left, or you could also just type in release all. That will basically have the same impact. Alright, so now we have done this part of code. Now I will just give it a really long delay, just so it won't like take over my computer. So delay of, let's say, 5000, so it will wait 5 seconds and then it will repeat. So it will move the mouse to a random location and then it will press it once. Then it will press once the left button. Alright, now I'm going to upload it. I'm gonna put my hands in front of the camera so you would believe me that I actually don't move with the mouse. And as you can see, it moved and it clicked. Now I will leave it running for just a little bit. And as you can see, it's doing it all by its own. So that is the mouse control. Right, so for the next code we are going to do some more breadboarding. So we have our breadboard with Arduino Micro in it, our jumper wires, and now we need a switch, momentary switch preferably, and a 10K resistor that has a color code of brown, red, black, black, brown. Alright, so let's wire up the microcontroller for our next code. Next code will be about that it will basically automatically search for a word and then it's going to write a string of letters. So, and I made it the code so you actually activate it with a push of a button. So this is our tactile switch which we're going to use. It's a momentary switch button and you can see it has 4 legs. And how does it work? Well, as you can see, those legs are in like certain orientation. They are parallel to each other, and in fact you can see it like this. You can see the 2 halves of the switches. So basically this half is all connected, so this leg is connected with this one, but it's not connected with this one and this one. But this leg is connected with this one, but it's not connected with this one and this one. And when you press the switch, it will actually connect them together to do halves. And that's how a tactile switch works. So I'll put in a breadboard, and then I'll need a pull down resistor. They'll actually pull the rail down once the switch is open. That means the pin 2 will be floating, and pin 2 is my sensing pin, and I don't want to be floating because then it can randomly trigger. So I'm going to put this 10K resistor which has a color code of brown, red, black, black and brown, and then I'm actually going to put a jumper so that when the switch is pressed it will actually let a positive voltage to flow across this resistor and into the pin 2. Alright, so let's connect the Arduino to the computer with the uploaded sketch. And actually, I forgot one thing. Put a jumper from the switch to the digital pin. Alright, so let's go through the sketch that I'm going to upload to the Arduino Micro. So first of all, we start with including the keyboard library. Then we define the I/O pin where we actually have the button connected. I have it on pin 2 as I've connected the button. Moving on into setup, we just initialize the library, and then in void loop all we do is we read the button, and if we read the button and we store the data in the integer start state, and then we check for the start state if it is actually 1, and if it is a 1, then we go through this procedure. If it is a 0, then it will just jump here. That means again on the start, and it will again read the switch. So if it is a 1, then it will follow this procedure. So this first line, what it does is it presses the Windows key, then it waits 100 milliseconds, then it releases the key. Now 100 milliseconds is like recommended. That's like the minimum that I think Windows takes. So, and if you're using Mac, you can actually refer to Arduino's website of how the pin mapping, the key mapping for the keyboard goes. So after we release the key, we wait 50 milliseconds and we start typing a string word, which will basically in Windows, you're going to press the start key. That means it's going to bring up the start menu, and then when you start typing, it will actually start searching. So I will be searching for Microsoft Word. Then I wait 200 milliseconds, so it will actually, I'm actually giving it some time to find it. Then I'm gonna press the return key or enter, wait for 100 milliseconds and release it, of course. Then I'm going to wait 2.5 seconds. Now I'm actually going to modify it to around 10 seconds, because on the first boot up the word is actually pretty slow, and then when it's like several times up, then it's actually the boot up of the word pretty fast. So I'm going to put it to 10 seconds. Then then the word is going to load in between. Then I'm going to press enter to actually, so the word will give me a blank sheet of paper. Then I'm going to wait 100 milliseconds, release the return key. Then I'm going to wait for 1 second to wait for the word to finish loading the GUI, and then I will print in a string called hello world, and this is what we should actually see on the paper of the word. Alright, so let's see if this works. I'm gonna put both my hands over here. I'm going to press the button, and then you will see how it actually does what I told it to do. So let's try it. And there it goes. That's a very simple program, yet it is really powerful. So there you go, that's how to program a 32U4 based Arduino. Now you can use these libraries also with Arduino Duo and Zero, but I'll save those for another video. If you want to buy the clone I use for this tutorial, there's going to be a link in the description, although I strongly not recommend buying it, as Micro or Leonardo are more worth it. Don't forget to like and share this video, and also consider subscribing. Until next time, bye.